Okay, so today we're going to look at some new formulas for segments in circles. We've got basically two formulas that we're going to need to know. Although you might notice on this page we have force equations. So the first one here is, notice that this situation is really similar to one of the ones that we looked at last class. Last class we were looking at the angles that are formed when two segments intersect like this. We would say, okay, this angle here is the average of these two arcs. But now we're not looking at the angles, we're looking at the segment lengths. So we've got this red segment here and this blue segment here, and we're looking at how long these pieces are. So the formula in this situation is A times B equals C times D. So notice that it's the two pieces of the same segment that are being multiplied together. So the red segment there, it's the two parts. They're not halves, but they're pieces of it. And that equals C times D. So it's like piece times piece of the same color one there. So if you have colored pencils, you can color code that. Okay. The second one here is also the same picture that we were looking at last class. Last class we were looking at the relationship between this angle and these two arcs. Now, similarly, we're looking at the segment lengths. So we have a red segment here and a blue segment. And we're going to be using this length right there. How long would that be? WX? W plus X. And then we're also going to be using this right here. What would that be? Y plus Z. So the formula is that it's the outside part, W, times the total length of the segment equals that same thing on the other segment. So the outside part times the total length. So outside times total equals outside times total. So that's two secants. A secant and a tangent. So this is actually the same formula. We're going to do outside times whole equals outside times whole. Except for the tangent, what would we call the outside part in terms of the letters there? What letter would we use? The outside part for the tangent, the red one. G. And then how would we describe the total length of that segment? in terms of the letters there? Well, how about just G? G is the full length. So it's the same formula, it's just we end up using that number twice. And the other one is the same, it's E times E plus F, just like in the last example. So same formula, just different situation. This situation we've already talked about. What is true about S and T? What's that? Down here? Outside times whole. Okay, in this situation here, what is true? True. What's that? Yes. If two segments are tangent to the same circle, then they are congruent, so S equals 2. Yeah, once you're done writing, we'll go to the next page. Okay. So on the next page, we're just going to rewrite those formulas. So now we've got different letters. What would the formula be for that one right there? A times B equals C times D. Okay. So again, A and B are on the same segment there. C and D are on the same segment. We multiply the pieces by each other. Okay, what would the formula be for this one? What letters do we use?
C plus D. Equals A. Times A plus B.
Nice. So the outside part times the whole thing equals the outside part times the whole thing. And then the last one. What did we get for the last one?
A times A.
A times A, which equals A squared.
Equals
B times B plus C.
All right. Nice. Okay. So we'll do a couple of examples together, and then you guys will do some. So for number 1 here, what would our equation look like? How would I solve for x equal 1? 10x
equals 14.
is 14 times 15. Nice. So 14 times 15 is 210. So x equals 2. So again, we're just recognizing the situation and using the formula that goes with it. Okay, let's take a look at number 6. Number 6, what equation would we use to solve for x? Okay.
plus C plus D. So 10 times 10 plus 42 equals 13 times 13 plus X.
Nice. Okay, so as we're solving this here, so again, that's whole times outside equals whole times outside. So that's X plus 13, 10 plus 42, it's 52. 52 times 10 is 520. What do I have to do on the right side there? Yeah. So we have two options. We could distribute the 13, or what else could we do? We could divide by 13. So we have two options. Distribute or divide. Mm-hmm. Yeah. Now, if 520 doesn't divide evenly by 13, I would probably go back and distribute, but I think it does. Yeah, because 13 times 4 is 52, so this must be 40, right? Pretty sure. Right? Someone back me up. 40. So yeah, we can divide instead of distributing, or we can distribute. It doesn't matter. We get the same thing. Yeah. So we get x equals 27. Well, actually, we're looking for NL. We're looking for the x plus 13 part. So actually, 40 is our answer. So maybe did a little extra work there. That's okay. All right, then let's go to number 9 on the back. So what would our equation be for number 9?
24 squared
24 squared
equals 18 times
Nice. Okay, so 24 squared is 576. What do we do now? Yeah, we can divide by 18. Or we could distribute. Dividing is going to be nicer because it's going to make all the numbers smaller. Right? If I distribute the 18 squared is like, what is it, 324 or whatever, and then 18x. So we have to divide by 18 anyway. So it's better to just do it at the beginning. What is 576? 14? Oh, the answer. Okay. So is that like 32? Okay. So 32 equals 18 plus x. We're looking for x there. Subtract 18, x equals